Hello, my name is Darian Lee, and welcome on my tutorial on how to solve using the quadratic formula. Thank you so much for watching. While the quadratic formula may be intimidating at first, the moment you get the hang of it, you can plug in any quadratic equation and always find the solutions for it. So I'm going to teach you how to use this magic formula, but before we jump into that, it's important to know what we're learning first. Basically, when we're solving using the quadratic formula, we're searching for the x-intercepts or the solutions on the parabola. So we're going to take the equation we already know, ax squared plus bx plus c, and we're going to put that in our new formula, the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. Just a side note, the ax squared equation has to equal 0 or else this won't work. So in order to make this easier for you guys, I've created 3 varying difficulties for quadratic equations, and I'm going to solve them all using the quadratic formula, and hopefully this will clear things up a bit. So as you can see, I've identified some values from the ax squared equation. I pulled out the a, b, and c to make things easier to plug in. So we've gotten, for a, we got 1, b, 3, and c, we got negative 4. So let's get started. Perfect. So I got the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a, and I just put the a, b, and c in their corresponding values for step 1. So for step 2, all I did was I simplified what was inside of the square root on step 1. I got 9 plus 16, which was from the 3 squared minus 4, parentheses 1, parentheses negative 4. And then after that, I just did 9 plus 16, which was 25. So basically, all we did in step 2 was simplify what was inside of the square root, getting 25 in the end. Now I'm going to go over steps 3 and 4. So basically what I've done was I've changed the square root of 25 into 5, and I have created a positive and a negative value, which some may get lost on. Basically, the reason why I've created a positive and negative value was because after the negative 3, there's a plus or minus sign, which means you have to do a plus and a minus. You have to do 2 different equations. This is probably the hardest part of the quadratic formula, but once you get this down, it should be a piece of cake. So in step 4, all I did was I simplified the positive and negative values, and I've gotten negative 8, 2, and 2 over 2. And then if you simplify those out in the end, you should get negative 4, 1, which are your solutions. So now we're going to do a little bit more advanced, some more advanced quadratic formula equations. For the a, b, and c values for this problem, I've chosen them to be a little harder because when you simplify what's inside the square root this time, we're not going to get a perfect square. But that's okay, because we're just going to go with what we know. So for step 1, we just plugged everything back in the quadratic formula. We get negative 150 plus or minus the square root of 150 squared minus 4 parentheses 2 parentheses 2. And then for step 2, all I did was, just like the first one, I just simplified what was inside the square root. So we get, inside we get 22,500, and then I just subtracted 16 from it, because from the 4ac from step 1. So for step 2, we end up getting the square root of 22,484. For step 3, I've simplified 22,484. I've taken the square root of it, and I got 149.9. And once again, we're going to make some positive and negative values. So we get 150 plus 149.9 over 4, and 150 minus 149.9 over 4. And for step 4, finally we get to simplify. So we get 0.1 over 4, and negative 399.9 over 4, and then we get our answer, 0.025 and negative 99.9, which are the x-intercepts or the solutions. So now we're heading into a more complex equation, and I've grabbed 3 values again. So for A, I've gotten 25, B, I got 0, and C, I got 1. You'll notice something a little fishy in the ax squared equation. Most people that are new learning the quadratic formula would say that there's no b at all entirely. but it's still there. You just can't see it because no one would put 25x squared plus 0x plus 1. So just a side note, the b is still there. That's very important. Although it's a bit different, the steps are still entirely the same. So we're just going to plug what we have, the a, b, and c values, and put them in the quadratic formula. So we got x equals negative b, or 0 in this case, you just can't see it, plus or minus the square root of 0 squared minus 4, parentheses 25, 1, all over 2 times 25. So step 2, once again, I simplified what was inside of the square root, and I've gotten negative 100. So for step 2, I've gotten 0 plus or minus the square root of negative 100 over 50. But hang on a minute. Mathematicians, or just anyone in general, if you try to take the square root of a negative number, it's impossible. It's impossible. You cannot do that. So doing so would require taking something outside of the real number grid. We would have to pull in a new variable labeled I for imaginary, because there's currently you can't get the square root of a negative number. It couldn't be positive or negative. No matter how much you try, you could never be able to get it. So instead of wasting our time with that, we're just going to pull in an I. Again, that stands for imaginary, and we're just going to treat that 100 as if it's just a positive. So the square root of 100 is 10, and then we're just going to take that I and put it to the end of 10. So the square root of negative 100 would be 10i. So for number 3, we're just going to solve like the other two difficulties. We're going to create a positive and a negative value. We're going to go x equals 0 plus or minus 10i over 50 equals 0 plus 10i over 50 and 0 minus 10i over 50. Basically, the only thing different from here on is that there's a variable on top, but we're just going to treat it like it's any other number. And for step 4, just like all the other ones, we're just finally going to simplify what we got. 10i over 50 is 0.2i, and negative 10i over 50 is negative 0.2i. Congratulations, you have just learned how to solve using the quadratic formula. Thank you so much for watching this video, and big thanks to Ms. Child for teaching me how to use it in the first place.